This video revises Pythagoras theorem. Pythagoras theorem is used for finding an unknown side of a right-angled triangle when two other sides are known. Pythagoras theorem states that the square of the hypotenuse side equals the sum of the squares of the other two sides. In the triangle drawn here, a squared equals b squared plus c squared. The hypotenuse side of a right-angled triangle is the longest side. It's the side that is furthest away, or opposite, the right angle. In these examples, we need to find the unknown side. In the first one, the unknown side is the hypotenuse. Let's call it x. Pythagoras theorem tells us that the hypotenuse squared is equal to the sum of the other two sides squared. So in this case, x squared equals 5 squared plus 12 squared. Working out those squares, x squared will equal 25 plus 144, or x squared equals 169. Now that's x squared. To find x, we need to take the square root. So taking the square root of both sides, we'll have that x equals 13 centimetres. The next question is similar. It is the hypotenuse that we're trying to find. We'll call it x, and we can say that the hypotenuse squared is equal to the sum of the other two sides squared. X squared equals 5.3 squared plus 7.2 squared. Work out what those squared numbers are, add them together, and then to find x, take the square root. X is equal to 8.94. Make sure that you're including correct units in your final answer. The next example is a little bit different. In the first two ones that we did, x was the hypotenuse side. But in this third example, x is one of the other two sides. When we set it up, we set it up exactly the same way. The hypotenuse squared is equal to the sum of the other two sides squared. So it's 15 squared equals 12 squared plus x squared. But we have to do a little bit more transposition to find out what x is. The first thing that we will do is evaluate those squared numbers. Then to get x by itself, we need to get rid of that 144 from the right-hand side of the equation. We'll do that by subtracting it from both sides of the equation. This means that 81 will equal x squared. Then to find x, take the square root. So x is equal to 9. In the last example, again, the side that we are trying to find is not the hypotenuse. But we'll start off by saying the hypotenuse squared is equal to the sum of the other two sides squared. 8.7 squared equals 3.2 squared plus x squared. Square out the numbers. Take 10.24 away from both sides of the equation, and we'll have x squared. Then take the square root to find out x. X is equal to 8.09 centimetres. One thing that you might notice when doing these questions is if the side you're trying to find is not the hypotenuse, then you should end up with a subtraction question in your workings. If, however, the side you're finding is the hypotenuse, it'll always be an addition question. Now, some people like to shortcut the process a bit, and it's okay to do this. If you realise that it's going to be a subtraction question because the side you're finding is not the hypotenuse, you can start your workings halfway through. In the third example, we could start from 225 minus 144 equals x squared, and that would save us just a little bit of time in our workings out. In this example, a flagpole is supported by guy wires which are 6.8 metres in length. They are attached to the pole 2.8 metres from its top and are anchored into the ground a distance of 2.4 metres from the base of the pole. We need to find the overall height of the flagpole. It's sometimes best, if you're working with a complicated diagram, to redraw the diagram off to the side. Now we're going to need to find x in this triangle here so that we can end up finding the overall height of the flagpole. It's a simple case of Pythagoras theorem. x is not the hypotenuse side. We'll start off by saying the hypotenuse squared is equal to the sum of the other two sides squared. 6.8 squared equals 2.4 squared plus x squared. We need to do a little bit of transposition here. We can work our way down and find that x is equal to 6.36 metres. Now that's not the height of the flagpole, because remember there's another 2.8 metres on top. So the total height of the flagpole is going to be 6.36 plus 2.8, a total of 9.16 metres. You'll find plenty of questions on Pythagoras theorem at the back of the book. They're worth practicing.